Hi, Jay. Morning.
Hi, folks.
Hi. What time is it over at your place, Jay?
Oh, it's 6 p.m.
Oh, okay, not too bad,
You,
right?
you're invited for us to join us for dinner, by the way. I don't know how we do that on virtual, but you're invited.
Hello.
Morning. Good morning from Thailand, everyone.
Good morning, everybody.
Eileen, I was asking Abe to give us a 5-sentence or 6-sentence summary of the session for the daily newsletter. We do a daily newsletter for the workshop. So he said he would. I just want to let you know.
Okay, great. Okay.
Just making sure I will do my job. I think we will wait for another five minutes because there are some people who is at Zoom now is sort of installing WebEx. So we'll give them a bit 3 to 5 minutes for them to come in and then we can start. Thank you very much.
Mhm. Jay, for your information, and VBEX is the platform that our university subscribe to. So if we didn't subscribe to Zoom and able to use Zoom, most probably it will cut off after 45 minutes and we have to rejoin again.
Oh, that's if you have free Zoom. That's true. If you have, like we do for the Ocean Best Practice Workshop, it's unlimited. So there's no limitations in the Zoom.
Because you subscribe to it, or?
Yes, I subscribe, but it also KikoChat subscribes. So
All
our
right.
platform for the workshop subscribes to Zoom and they make all the arrangements.
Okay.
Yeah. And
Because
that's
there's
for
one,
next time.
yeah, because there's one thing we did not inquire earlier, by the session chair, whether we can use the OBPS platform or not, rather than the
Yeah.
Zoom platform.
Yeah. Yeah. We'll advertise it better next year. So it's easier for people. I appreciate most people may not have understood. Yeah.
Okay.
Maybe just 1 more minute because there's one more person coming in from Zoom. Just give 1 more minute, then we'll go ahead start.
We have another speaker who is not in yet, right?
No, everybody is here. Dr. Masa is unable to join us, but he
Oh,
sent
okay.
me a recording of a lecture yesterday. He quickly have done it yesterday because he is in the field and he couldn't finish his sampling due to bad weather, so he is stuck somewhere in the
Okay.
coastal area somewhere. Yeah.
Mhm.
Okay. Yeah. Hi Sam. Sorry about it. You have to come in from Zoom and change to WebEx. Thank you for coming. Right. Um, I'm still logged on Zoom on the other side. So if there's any more participants that wants to come in, I will direct them to here. But let's go ahead to start our small little workshop on seagrass monitoring. So basically, we have put up 3 speakers for today, and um, 3 of our speakers are from this side of the world. But we are hopefully that there are more researchers that is gonna come in, that they're gonna come in and share their views. But online now we have Prof. Eileen, who co-chairs with me this workshop, and then we have Dr. Anjana. Can you wave, Dr. Anjana? Yeah, she is from Thailand, and she will be our second speaker. And then we have Professor Mike. Professor Mike, I can't see you. Yeah, all right. That wave. Yeah, this is Professor Mike from the Philippines. So he will be our third speaker. As I said just now, our first speaker is unable to join us online at this moment, but he have kindly sent me his recording of his lecture. So first we will go to him, Dr. Masahiro Nakaoka. So let me briefly introduce Dr. Nakaoka. Dr. Nakaoka is a professor at Hokkaido University, as well as the director of Akeshi Marine Station. He is much involved in actually she co-chairs the Asia Pacific Marine Biodiversity Observation Network, and he is also one of the co-chairs for Marine Biodiversity Observation Network internationally. His works revolves around the interaction between animals and seagrasses, as well as he is a member of IUCN SSC Seagrass Specialist Group. So unfortunately, he is unable to join us today, but if you allow me, I will play his lecture that he has sent me. Okay. Can you see the video?
Yes.
Right. So let me start playing. If you don't hear anything, please let me know. Just give me a moment, right? I will try again. I couldn't play it from here. All right. And
My name is
We cannot hear the voice. Abby, there's no audio, yeah, Abby?
AB. We still can't hear. Maybe can you allow me to try? I have the video as well.
you can't hear the video
No,
No.
at
we
all.
can't hear.
No, we
Oh.
cannot hear.
Can
Maybe
I
I'm so
try
sorry.
to share my screen
Yeah.
instead?
Yeah, please do.
Okay.
Let
Give
me
me a
stop
moment,
sharing.
yeah.
I'm so sorry about it.
Sorry.
Still no sound, and
Seagrass ecosystem.
okay,
My name is
yes.
Masahiro Nakaoka of Akechi Marine Station, Hokkaido University. I first briefly introduce about myself. I'm working for Field Science Center for Northern Biosphere, Hokkaido University, and my area of expertise is marine ecology, especially studying relationship among biodiversity, ecosystem functions, and ecosystem services of coastal areas, with special reference of seagrass ecosystems. I'm working for several international academic services, such as I'm a co-chair of MBOM, Marine Biodiversity Observation Network, and I'm responsible for APMBOM, Asia Pacific Regional Group of Marine Biodiversity Observation Network. And I'm also servicing as IUCN Species Survival Commission, Seagrass Specialist Group, and I'm working as an editorial board of Estuaries and Coast. Just a brief explanation of where I'm studying. I'm working for Akechi Marine Station, which locate in northeastern part of Hokkaido, Japan, which is actually nourished by very cold Oyashio current with water temperature going below -1 degree in winter. But it is very productive system full of high quality seafood like oysters and very pristine with less human impact. In this marine station, we've been working a variety of topics on marine ecology, such as biodiversity functions and services of marine ecosystems, marine plant-animal interactions, land-ocean interactions, and the evaluation of the effect of climate change on marine ecosystems using a variety of methods and devices. Today, I introduce especially on seagrass bed ecosystems, but before that, I'll briefly mention about marine macrophyte beds, which is an area where large seagrass, large marine plants occur in a nearshore habitat. It's one of the most important coastal habitat, in addition to coral reef, mangrove, intertidal flat, salt marsh, and rocky shore. There are two types of marine macrophyte beds in the coastal ecosystems of the world. One is seagrass bed, macrophyte bed consisting of seagrass, marine flowering plants. And another is seaweed bed, which is macrophyte bed consisting of brown algae. So they are very different, of course. Generally, seaweed bed occurs in a rocky shore or hard bottom, whereas seagrass bed occurs in a soft bottom, sandy or muddy bottoms, and they have roots and rhizome systems in case of seagrass bed, while seaweed usually attached to firmly to the hard substrate. As most of you may know, seagrass is a marine flowering plant which have actually evolved on land, and some of the lineages came back down to the ocean. For example, one of the species of seagrass, Zostera coalescens, which occurs in Japan and Korea, has some space which has the seed inside. Such marine flowering plants are known about 60 species in the world and about 20 species in Japan. Molecular phylogeny studies conducted in around 2000 shown that these seagrasses come back from land to ocean in 3 independent groups. As shown in this is a phylogenetic tree of seagrass and related species, and there's 3 lineages coming back from its freshwater or terrestrial origin to the ocean, which is shown by these broad red lines. One group is actually Zostera species, which in temperate region, whereas other 2 lineages, actually 3 families, are actually tropical species. And the molecular clock actually told us that they diverged from terrestrial or freshwater origins at around 100 million years ago. The seagrass bed has various ecosystem functions, some of which actually benefits our human beings as well. Summarized as 3 following points. First, they are major primary producers, and their habitat is one of the most productive sites on Earth. Second, they support high biodiversity of a variety of different types of animals and plants, and they provide habitats for commercially important species, fisheries resources, and also some endangered species. And third, they are actually called major ecosystem engineers. This is a kind of organism that has a strong impact on surrounding environment. In the case of seagrass, they affect water quality by absorbing nutrients. They change water current by its complex above ground, and they stabilize sediment by their below ground parts, rhizomes and roots. First, I will briefly talk about first function, major primary producers. Please have a look at this video. You can see a lot of bubbles attached on seagrass blades, and also most of them are coming up in the water column. So you know what type of gas it is. It is oxygen, which is a product when does photosynthesis. So oxygen is generally can absorb in water quite a lot, but because their production, activity of photosynthesis is very high, most of the oxygen gas cannot absorb in the water, and it can just come up as a bubbles. Based on this high efficiency of photosynthetic activities, their growth is also very high, very rapid. This is again one species which I studied before. Is a Zostera coalescens, temperate species occur in Japan and Korea, and we observe, monitor the change in their shoot height or canopy height from December to August. The average shoot height was less than 2 meters in December, but they grow very rapidly, almost 5 meters in half a year, and reaches to the maximum height of 7.8 meters. It is the world's tallest seagrass in the world's tallest seagrass. In ecology, we can compare the productivity of different type of ecosystems using the measure called net primary production, which means the new plant body in terms of gram dry weight per square meter per day. And when comparing different type of ecosystems in the world, blue is aquatic ecosystems, and triangle green is forest, and the blue green square is grassland. When we compare net primary production, seagrass bed is actually in the middle, about the same as salt marsh and the temperate forest. But please also have a look at the x-axis. It is a biomass, dry weight of plants per square meter, and it is actually plotted against logarithmic scale. Compared with temperate forest, the biomass of seagrass is just 1/100th. So it is very small, but still it has a high productivity. So we can say seagrass bed is small in biomass, but they have a high productivity. So quite efficient primary producer. Okay, let's move on to the second functions of seagrass bed, which is actually supporting high biodiversity. If we observe in the seagrass bed by our eye, we can find a variety of different type of animals. It is a kind of example of different type of invertebrate species we can find in a seagrass bed, a variety of polychaetes, crustaceans, mollusks, and other animals that which is very unique, echinoderms or tapeworms. And we can compare how is it different in terms of biodiversity and the biomass of animals inside and outside of seagrass bed by comparing the animal abundance using the same method between inside and outside the seagrass bed. And this is just a case example of the number and the species richness of benthic invertebrates in a seagrass bed in one seagrass bed in Japan. And you can see a number and the species richness is nearly 3 times higher inside than outside of the bed. We already got a lot of similar type of result papers showing that this kind of result. Of course, there's sometimes an exception. Outside may be much higher, but most of the case, seagrass bed hosts higher number and biodiversity of associated animals. And these animals and plants are actually linked by trophic and non-trophic interactions. Trophic interaction is actually who eats food. Non-trophic is interaction not linked by the energy transfer, but actually seagrass provides habitat provision to small organisms like epiphytes, attached microalgae, mycetes, and small animals and large animals like shrimp and fish. For the energy flow, seagrass is rarely eaten by invertebrate species like mycetes and shrimps, but they are eaten mostly by vertebrate grazers. Here in my study site in Akeshi, it's eaten by the whooper swan mostly during winter. For the small herbivorous species like mycetes or snails, they do not directly consume seagrass except for several minor species, but they feed on epiphytes, which is attached microalgae like diatoms on the surface of seagrass or on the bottom. And those small grazers, mesograzers it is called, is eaten by a variety of different type of carnivores, some of which is very important for the other fisheries target. The story never ends in this section. In our my study site, Akeshiko, it is famous for the aquaculture of bivalves, clams and oysters. And mostly in the textbook, food of bivalves actually is called their phytoplankton or any particulate organic matter suspended in the water column. But here in Akeshi, most of the suspended particles, organic particles, are not phytoplankton, but benthic microalgae, which attach on seagrass, and actually we already know it is a major food for our special products. So without eelgrass, we can't support much good seafood here in Akeshi. Okay, we can further study food web structure of seagrass bed. Sorry, it is in Japanese, but the lowest columns is plants and the detritus, and the second level columns is a variety of different type of herbivores, grazers, from swan to small invertebrates, and they are eaten by different type of small carnivores and then higher level predators. The top is here is carnivorous birds of prey like white-tailed sea eagles or stellar sea eagle. So we have a complex food web in Akeshi originated from our seagrass bed. Okay, let's go to the third function seagrass bed provides. It is actually changing environment, and they're called as one of the important ecosystem engineer, affecting water quality or water current hydrodynamics or sediment profiles. Okay, it is just a schematic view how seagrass bed or eelgrass bed in Akeshi is changing the environment. First, they suck not only carbon dioxide, but also nitrogen and phosphate as a major nutrient, which changes water quality. And actually, they shed leaves very frequently. So the dead leaves actually float and drift away to the offshore or accumulate on land. So they have also impact on different ecosystem types. And the below ground and some of the leaves, which has a heavy epiphyte load, will deposit it in the sediment. So that is actually how the materials from seagrass goes away. And we can classify some of the ecosystem functions which benefits human beings as ecosystem services. Ecosystem services is actually something we are actually given by the natural ecosystems at the moment without any charge. But it is very important. Actually, according to Millennium Ecosystem Assessment, ecosystem services are classified into 4 different types. Provision services is products obtained from natural ecosystems. Regulating services is benefits obtained from regulation of ecosystem processes. Cultural services is something like non-material benefits people obtain from ecosystems. These 3 are direct services, and these services are supported by basic services. Those are necessary for the production of all the other direct ecosystem services. And in the case of seagrass bed, I think most important provisioning services is seafood provision. But there's other type of provisioning services like fiber, fertilizer, salt production. For regulation services, which I just explained in a previous slide, water purification, nutrient and carbon fixation, sediment stabilization, and so on. And there are several cultural services, which is something like environmental education, recreation, and ecotourism, and authentic values or regional values, and so on. And the supporting services is photosynthesis, primary production, nutrient cycling, etc. Compared to other major ecosystems, we can't think much about the cultural services, but if we investigate a lot of local cultures, we can find some interesting things. In Japan, in one region of Japan, the use of seagrass for the steam sauna, it's called Amamoburu, was actually, it was a unique custom. People just enjoy, hot spring or steam sauna with laying seagrass, which they say it's good for your skin. Unfortunately, the final seagrass sauna was already closed, so we can't take it anymore. And another interesting cultural services is actually seagrass leaves are used for pottery in one part of Japan, and it's called mogake. Technique is called mogake, and it has a unique structure, which may become a very interesting and very valuable pottery. Okay, for the classification ecosystem services from seagrass bed, recently we have a lot of attention. Lot of attention has been paid on the role of carbon fixation, which is known as blue carbon now. It is a bit old data, but basically actually climate change, global climate change is mostly due to our use of excess fossil fuels, which actually increase the amount of carbon dioxide and other greenhouse gases in the atmosphere. And half of the emitted gas is actually sucked up, actually absorbed by ocean, and another half by green forest. And in 2009, the assessment report called about blue carbon showed that some coastal habitats like mangrove and the seagrass bed has a very high capacity for absorb and actually keep carbon in the ecosystems. So the role of marine ecosystems for absorbing and stocking carbon dioxide, the organic organic matter has been paid attention since then, especially compared to the terrestrial forest. Mangrove has a high capacity for ecosystem carbon storage. Seagrass also has a good capacity as soil part of most terrestrial forest. Of course, variation is very high. Based on these ecosystem services, some environmental economical analysis has tried to evaluate economic value of these ecosystem services. And this is one paper, famous paper by Constanza et al. In 1997, appeared in Nature. And according to this paper, seagrass bed has a very high ecosystem value, economic value, as large as estuary in terms of US dollars per hectare per year. And it is much higher compared to tropical rainforest. It is 10 times higher, and even with the coral reef, it is 3 times higher. So it is very valuable ecosystem worth conservation and restoration. However, we know, as in other important ecosystems like coral reef and mangrove and other marine habitats, seagrass bed has been declining rapidly from the world due to a variety of human-induced causes. Mr. Wycott and their group actually reviewed all the temporal data on the change in seagrass bed area and found our seagrass bed in the world were disappearing at the rate of 7% per year at least by 2009. But this is the data, and actually you can see most of the quantitative data, temporal change data, comes from developed countries like US and Europe and Australia, but less data came from our region, Asia. But as we already know, it is the area where the seagrass diversity is the highest in the world. So we need to add more data from our region of Asia. So some of our researchers actually in Asia collaborate to examine the temporal change and current distribution status and temporal change and conservation status of tropical seagrass bed in Southeast Asia. And actually we published this paper last year, and we actually renewed more than 2,700 GIS data on seagrass bed distribution in Southeast Asia since 2000. And some of these data has temporal data, and we analyze the trends as Wycott paper, and found again we have a lot of seagrass bed in especially China and Vietnam coast has a decline, and based on the average, it is actually declining at the rate of more than 10% per year. It is still serious condition. It is 1.6 times greater than the global average. We also actually learned what is the major causes for the decline, and there's by different countries. According to this data, still coastal development, aquaculture, and destructive fishing reported as a major human factors causing decline. But there's also a report showing the natural factors such as flood, typhoons, tsunamis, also major cause. So we need to consider both anthropogenic and natural factors for the change of temporal change. Okay, so we still need a lot of effort to change the trend of the world seagrass bed decline. And what I want to insist is actually we need to try not only by scientists or by stakeholders, but we have to have a good relationship and develop a good practice to efficiently conserve and restore these important habitats. It is actually a famous figure showing the ideal triangle for ecosystem management. We need three components: monitoring, research, conservation, and management. Monitoring is actually very important. Without monitoring, we don't know whether seagrass bed is increasing or decreasing. And research is to know the mechanisms how this change is observed. And with these scientific data, we can proceed conservation and management effectively. For this part, it is not only by science, but we need the involvement of multiple stakeholders, and we need to make a wide decision based on scientific data. This session is especially focuses on monitoring, and I hope you can learn a lot how it is important to continue monitoring, carry out monitoring in Seagrass. Thank you very much for listening, and I hope you enjoy the rest of the talks and you learn a lot. And for my talk, if you have any questions, just contact me this following address. Thank you very much.
Okay, thank you, Dr. Masa, for preparing a video for us. We are sorry that he is unable to attend personally, but if there's any questions that you would like to post on it, we will pass the questions to him, and then we'll keep in contact with everybody. So to summarize that, the first speaker is meant to introduce, in general, the functions and the importance of having the ideal triangle. So one of it is monitoring. So I would like to now invite our second speaker, Dr. Anchana Pratip. Dr. Anchana Pratip leads the Seaweed and Seagrass Research Unit at the Prince of Songkhla University, Thailand. Her work focuses on seaweed and seagrass ecology and ecosystem services. She recently also tries to understand much more about seagrass and seaweed's contribution to carbon sequestration and storage. So we will hear a little bit more from her on her perspective on monitoring, as well as the perspective on how then we measure as well as monitor the carbon sequestration system and blue carbon system in seagrass area. I would like to welcome Dr. Anchana. The floor is yours.
Okay, thank you very much. Thank you, Abe. Good morning from Thailand to everyone. So allow me to share the screen here. So at first, Professor Nagaoka already mentioned, give you a very good overview about the seagrass, and then he also have a touch on the carbon fixation and the blue carbon, right? So I'm going to go a little bit deeper in terms of the blue carbon, which is quite become a very strong keyword at the moment for the seagrass ecosystem. But I want let you guys lose sight about the whole of the seagrass ecosystem as a whole. It's quite important. But the blue carbon is going to give us a good opportunity as well to really conserve our seagrass, with again it's being mentioned that it is in a very sharply decline there. Okay, so I'm from the Seaweed and Seagrass Research Unit and belong to Prince of Songkhla University. Our study basically start from the seaweed ecology, and then later on, when we have a chance to explore more about the seagrass, actually at the very beginning, I'm being introduced about seagrass by also Professor Mike Fortes, with also a panelist session here. So hi to you, Mike. Let's go into detail here. So as mentioned, we are very much in the hotspot of the seagrass, as again already mentioned by Professor Nagaoka. So we actually right there, we should be able to have a good understanding of this precious ecosystem. But again, as we see it, we still have a lot of big gap that we have to fill, and opportunity alive because of this blue carbon and the climate action. So what I try to put again in the concept of how the blue carbon or the seagrass can help with the climate action, it come as a under of the concept of nature-based solution, which actually being to emphasized by the IUCN. And at the moment, it's become a very good issue for us to be able to put a very strong tie of the people together to try to build on the knowledge and understanding about the blue carbon, and then hopefully build on into the other biodiversity or ecosystem service. To just underline again the importance of the ecosystem service. At the very beginning, it's very close tied to the human livelihood, so that how people get to understand and learn more about the seagrass ecosystem service. in Thailand, we understand that we have a lot of problem with the coastal erosion, but for the research, we still have the big gap for the research. We don't really have a good understand how much the seagrass can contribute to the coastal erosion and become the issue with the blue carbon because of the attention is on. So we have a chance to really have a good understanding and a good research on the blue carbon, which I'm going to elaborate later on. So to just have a overview why blue carbon become as important nowadays, because the potential of the carbon storage. The concept is if we destroy or if the ecosystem the decline, so the carbon will release back to the atmosphere. That's one of the concept that why we have to have a good conservation monitoring could also keep our resources there. So that's one of the concept. So why it's become so important? If we look at this graph, we also going to see that the blue carbon in the coastal ecosystem has a much higher than the tropical forest. And where are those carbon? Actually, it is being stored in the soil organic. So when we want to study about the blue carbon, we should underline the importance of the soil organic, right? That's where the carbon are, right? If we look at the biomass, of course, the tropical forests have a much greater biomass, so that they are plus. But for us as a coastal ecosystem, the soil is there, and that's where the carbon storage is. So this kind of concept and manual is already put out there. If we want to study the coastal blue carbon, the IUCN, the CI, actually Professor Mai is one of the keynote to build up this manual. It's already there and it's being used for some time already. But the blue carbon is become much hotter because of the COP26. And then they also put up this kind of blue carbon partnership policy in action. They even put up all the scheme. If we want to have this carbon helping with the climate action, right? Everyone is going to be a very key important role. The international framework who are going to be the key player is already being adopted. In terms of national level, if we want to have this as a nature-based solution, as a blue carbon to help with the climate action, leading the country to carbon neutrality, as the government already pronounced. So this is what we have to do, right? And then at the committee level, so to be able to accomplish, understand, have a good blue carbon study, luckily we have a good manual there. So it's not that hard. And the monitoring, and then some of the study is already out there. So I'm going to give you a quick video of this is an example that we has been carried out in Thailand, just to see if we want to do it, how we going to do it there. Hang on, I'm not be able to the slide presentation play here. Okay, so that's just going to give you a quick recap of how we're going to access the organic carbon using that standard method from the Blue Carbon Initiative project. So the most important and the keywords that I would like to underline would be the size of the core. It should be standard as a 1 meter. And then you have to try to get a sample as deep as 1 meter. But it's okay if you cannot get the sample as deep as 1 meter, because sometimes when you are in the field, there is some problem, certainly. But with those kind of manual, it's going to allow us to have a kind of standard method to be able to compare our study, and it's going to be able to share and really understand the carbon storage. Or later on, it's going to be hopefully for the carbon credit and help with the GHG reduction and so on. So that the keywords about the organic carbon, blue carbon in the seagrass ecosystem. But on the other hand, we cannot really lose sight about the biomass, because in this tropical, we have somewhat of the 13 species. And probably the big species like in Halas, certainly they have a bigger biomass. And probably a chance that they can trap sediment may be higher than the smaller species. So again, the biomass, the species on the top also should be considering. Even the biomass as a carbon is not much, but the role in terms of being able to trap the sediment could be another important critical that we should look at as well. So this is just to give you the picture. When we do our study, we divided into the big seagrass, the medium seagrass size like Thalassia, Cymodosia, and then we have the smaller species like Halophila. So that's how we categorize our seagrass. When we do our study, as a field ecologist, we are going out there. Our standard tool would be like Tansec and also the Quadrat. But nowadays, because of the technology become much more available, it's also allow us to have a good capture of the landscape. So we also adopt the drone. Drone has a good advantage because it also can allow us to have a big area as mentioned, and it's become cheaper available. So it is become easy to access, and to be able to get it going is not that difficult. It's become very handy nowadays, I would say, and I would like to probably promote it as a citizen science or monitor if it's possible in the region. The other technology with the remote sensing, like Lancet or other uh, out there, like Sentinel or whatever that they have, this also going to be a very good tools for us to really have a big, large area to monitor the seagrass. One of the example that probably we can show is we pick up this Lancet 8 data or even Lancet 5. So it's allow us to really go back to time with the temporal change. So we would be able to understand how decline or how changes the seagrass are in the area. So this remote sensing, Lancet 5, Lancet 8, which is now become very available. So it's very handy. The drone technology is become cheaper, accessible. So it's also very handy for the seagrass monitor. We also adopt this kind of technology to study our coastline. So if we look at it, we're going to see like mangrove, we have a much higher of the carbon storage over here. And then if we have the mixed healthy seagrass, the number of carbon is also high. But the unhealthy seagrass, the number of carbon become much lower. Then as we are in the seagrass and seaweed region, we also have some of the study of Halimeda, which is also common in the tropical, and it's provide different carbon, like inorganic carbon. So they also have a mix here. So we can see that the transit over, we're going to be able to access the amount of the carbon throughout the coastal line here. And to emphasize is, okay, probably mangrove and healthy seagrass has a much higher carbon storage over there. And if we cannot keep up with our seagrass health, the carbon storage is going to become much lower. This is the model that we kind of develop. It's quite simple and it would be easy. So basically, you just start up with the simple technique. Go out there using the line transect quadrat, and you start with your coverage of the plant. And then our postdoc, Dr. Milita, is the one that doing this kind of model. So for us in the region, because of the technology might be limited, and in previous research, when we do the monitor, we just only have the coverage. But those kind of data is going to become very healthy and useful as well through this. I'm not going to go into the detail, but then you can follow up looking into our research article there. So with this, we are able to come up with some equation, some number. So with just simple coverage put in there, at the end, we should be able to get estimation of the carbon storage in the area that you are interested in. Again, just to emphasize, when we look at it, the carbon storage, healthy seagrass has a much more carbon storage than the unhealthy seagrass. The uniform seagrass has much higher than the mixed seagrass species. So to emphasize the research is also important, as Professor Nagaoka mentioned, to keep us into the detail. Ability to trap the sediment, as mentioned, so it's going to go into the biomass vegetative type. The Halimida, that the seaweed, has much greater, actually, the ability to trap the sediment than our large enhalas. The mixed species has a much higher trap setting than the uniform seagrass. This is understandable because of the complexity of the organism could help trapping the sediment. But then those sediment is going to be trapped and then stored into the bed, and it's become this blue carbon. Also, to be able to understand the bigger picture and to complete where to conserve, we should be able to understand the source, where the source of the carbon coming from. We have one of the study. So in this small bay, we just understand that, okay, within the seagrass, actually, the seagrass itself contribute the carbon source, carbon storage, 22%, right? But then our seagrass is actually trapping the carbon from the terrestrial and mangrove. So with this kind of information, again, it's going to help us to be able to identify where to conserve, how to manage the upland, or which particular mangrove or which particular seagrass that we should conserve and manage. So just to give you the example, some of example that I like to show, as mentioned, we adopt the Lancet data. This is one of the example that we focus in Trang using the Lancet data in 1999. And then we use it, looking at the temporal change through time every 5 years. We are able to really identify that the seagrass area is declined. And then mapping it with the land use, we're going to be able to say that what kind of threat that actually influence the decline. So I encourage you to really go back, look at your previous data. That's it. It's going to be handy there. And then with this, because of carbon, blue carbon is become very much more needed. So we convert it using the previous model. We didn't really have the carbon storage at the beginning of time, right, in 1999. But with the model that I already mentioned in the previous slide, so we are able to really identify how much the carbon is being stored and is being released back because we are losing the seagrass area, right? So further information can look into this article, right? And then with this, we are able to understand probably the development, the land use, causing the seagrass decline, and again, we are losing back the carbon. So the concept probably when we are talking about nature-based solution, when we are talking about blue carbon, one of the concepts should be about the conservation of the seagrass. Because restoration is not easy, but this is something that we can simple do by the conservation, right? And a very good tool and important would be to monitor, keep up how the seagrass is doing there. So just to make sure that we have a good, healthy seagrass to begin with, and we can manage everything in time if the threat coming in. Because again, restoration is not easy and it costs a lot. This is another example. Just using that simple model to begin with, we are able to put up some of the map to look at that how much carbon being stored in the Southeast Asian region. If we do nothing, and then we know that if the carbon, the seagrass decline, we're going to release back the carbon dioxide back to the atmosphere. But if we just having a good conservation, and because we understand that the seagrass itself is grow fast, so with this, it's going to be able to increasing the area by itself, and then also help with the carbon mitigation to 6 to 7% for the carbon reduction goal. This is just some of the example, and we are able to identify using that simple model carbon, right? So we are able to break down into the carbon organic accumulation, carbon assimilation, and then because of the value, ecosystem is quite high as well. So just to give you some of the example. Okay, so what I like to ask probably just that simple model. If we just share the data, right, using your data, having your coverage data, so we can share together the information, we would be able to understand how much the carbon storage, carbon stock in the region, in the area that you are working in. And if you like to do that, you can scan our QR code, and then this Excel will come up, and then we can really build the network simple enough to really understand about the blue carbon and carbon assessment in the area. So that's about it. Thank you.
Thank you, Dr. Anchana, for a very, very interesting lecture actually. And I'm extremely also attracted to your proposal on renewing the way we sort of do monitoring, especially employing now low cost kind of drone system that we can easily, come up with some best practice also, because I have not seen any document that really standardize the way we look at newer technology of monitoring the seagrass. If I do not know if we want to have the questions like at the end of the during the discussion, or if there's any burning questions that you really want to ask before you forget. I can accept one or two. Okay, we have one very quick one in the chat box. Dr. Anjana, how are the drone photo data sets being stored over time? Are other researchers storing the images on the same platform? And are the drone photos being stitched together to cover the whole area? Dr. Anjana, do you want to have a quick response to it, or we can bring it to the discussion also later?
Uh-huh. We have a team that really looking into this it's another kind of doing methodology, right? So it's image processing and all that. So we have another person that doing this. We don't really have a platform that sharing yet. We just all have our server that storage that. And if anyone is interested, we can arrange a kind of workshop to really have a good understanding on stitching the image, how to classify, and then have all this information. Yes, but I don't think internationally we have the platform that sharing this information yet. Okay.
Thank you, Dr. Anjana. Maybe we can bring this to the discussion later. Sam, maybe you can have some interaction with her later on in the discussion session. All right. We're gonna move on to our next speaker, Professor Mike. Let me quickly introduce Prof. Mike. Let me bring out his CV. So, Professor Miguel Fortes is a retired professor of marine science from the University of the Philippines. His work in seagrass has stretched over 30 years in many, many places. I think whoever studies seagrass will definitely have heard of him, will definitely have met Prof. Mike. And of course, I do not need to read all of his accomplishment throughout his 30 years of work with seagrass area. So I will just leave it to him, and we'll see how he has developed or helped him develop a kind of protocol for seagrass monitoring internationally. Prof. Mike, may I invite you to share your presentation.
Thank you, Abby.
I will, yeah, I will
Okay.
be
Yeah, please.
sharing his presentation. You
No,
just have to speak.
so first things first, I'd like to thank Abe for, he's going to run my slides for all of us. Something went wrong with my system. So, and the other thing I'd like to thank, I'm very thankful for Dr. Massa and Dr. Anchana. Not just because we are all familiar with each other, but because the two have provided us a very vital information that will make us understand more about seagrass, especially what I'm talking about. That means I'm not going to repeat what has been said, although I'm going to elaborate some of them. Okay? Now, this is my topic. Please note it's a community of practice. To contrast it from the first two papers, this time I will not be dealing too much with scientists, but I will be dealing with communities. Then emphasizing what's best practice in seagrass monitoring involving the communities. Next slide, please, Abe. Of course, my main points. What are the aims, objectives, and even the learning outcomes of this presentation? And of course, number two, the importance of seagrass ecosystems, which really justifies their sustained research and monitoring. Three is what we need to know for best monitoring outcomes. Four, the COP. Why is it the best approach to solve the problems of seagrass? And then I'll end up with a very brief set of challenges and take-home messages. Next, please. Okay, for aims objectives, I have underlined the keywords. One is sustained seagrass observations. I am very happy that in the region, Southeast Asia, there are some signs that monitoring of seagrass is being sustained. And we are going to promote best practices thanks to Eileen and IOC Westpac for introducing this concept because it's very vital. And then number three, presentation of practical and affordable as well as state-of-the-art methods. Just quite briefly. And then the outcomes, of course, would be access to standardized methodologies. And then seagrass EOVs, as some of you may know, EOV is essential oceanographic variable. For seagrass, it is seagrass density and cover. Number two, enhanced local and national networking and collaboration opportunities. Three, identification of further training needs for the region. Next, please. Okay, I am summarizing what Professor Massa has mentioned to us. There are 10, I'm presenting them here. And if you start with what have the upper row, you have, it provides fisheries, regulates climate change, buffers ocean pH, preserves cultural heritage, enhances tourism. And then the next row below, protects biodiversity, protects the coast, filters seawater, connects habitats, and controls diseases. I have incorporated some of the more recent functions They're not well known yet. So with this, in our meeting in Norway, we concluded that indeed seagrasses are the unsung heroes of our oceans. Next, please. 5 fundamentals for best seagrass monitoring outcomes. And thank you, Abby, for changing my mistake there. A, basic and unique features of local seagrass and their ecosystems. We have to know. And thanks again to Masa and to Anchana for starting with these facts. B, you have to know the critical and lesser known functions. C, the issues and concerns they face. D, useful concepts like, for example, the levels of organization, impact, interaction, all of those concepts are very useful in monitoring. And E, the complete set of steps essential in the monitoring process. This 5th fundamental is one that is almost always neglected, forgotten, but I'd like to emphasize it later on. Next, please. So what do we have to know first? Of course, what do we have in terms of seagrass? Our latest publication, 2018, we have about 21 species in the region out of the global 60. So we're very rich, one of the richest, if not the richest. Of course, Australia has the most number, but also because they have the best taxonomies, and the studies are really quite amazing in Australia. But we are trying to follow it up in our region. Next, please. Next thing that we should really know first are the special features of seagrass in order we can monitor it best or pinpoint exactly what we want to monitor. First, of course, is that they are flowering land plants that evolved to live in the sea about 100 million years ago. And then the survival in the marine environment is via reproduction and morphological convergence. Very simple. Reproduction and morphological convergence. They can tolerate a range of salinities. Light is most important factor for growth, requiring 5 to 29% of surface light. And water temperatures greater than 40 will stress seagrass. And death occurs at temperatures greater than 45 degrees centigrade. Most seagrasses live in sand or mud sediments. That's why you can find them in estuaries, shallow coastal locations, or non-reef ups between mean sea level and 25 meters of depth. The 5th special feature is that worldwide, only about 12 major divisions consisting of about 60 species. And then 6 is that the highest concentration of species of seagrass occurs in the Indo-West Pacific region. As you can see there on the right, the global seagrass distribution is the 3rd time that this has been shown here in this session. Note where we are. Note where the hub of seagrass distribution is. It is in our region. Next, please. Now, the lesser known functions of seagrass ecosystem. 1, seagrass ecosystem connects, protects, and sustains coastal habitats. As the figure shows there, the location of seagrass is very strategic. It does not protect, but protect from what? Seagrass protects the coral reefs from the influx of sediments coming from mangroves or upland. On the other hand, seagrass protects the mangroves from waves from the sea. And note also, I am trying to distinguish habitat connectivity, and it's between 2 of the same habitats, coral to coral, seagrass, or mangrove to mangrove, and then the seascape connectivity among the 3 ecosystems, even including the terrestrial habitat. Next, please. We should also know that seagrass ecosystem supplies nutrients to deeper and distant parts of the oceans. The upper left figure would show you that as a blue carbon ecosystem, together with mangroves and of course the tidal marshes, the coral reefs there, the nutrients or the carbon that's produced by the system is brought down at depths in very different forms. But this is not so well studied as yet. So we consider this only as oceanic blue carbon. We are, and we'll try to discuss the first two papers, and then mine is coastal blue carbon. But there is such a thing as an oceanic blue carbon. And also, it supplies nutrients to distant parts of the ocean. Can you imagine? Very few works, and this one is the isolated work in Kenya, showing to you the benefits that other regions of the world derive. And this is in terms of US dollars. This work is increasing, by the way. Next, please. We also should know that seagrass ecosystem adapts to the effects of the rise in sea level, carbon dioxide, and temperature. As I have shown here, with sea level, the effect is almost always twice double. There is a positive one designated by the positive sign because it creates new habitats at the uppermost level. On the other hand, on the lowest part of the bed, there is submarine erosion. So it's positive, negative, and they cancel out. So in a sense, it's a winner. There's no net negative or no net positive effect. And the same is true with increased CO2, increased photosynthesis as the positive, reduced calcification as the negative aspect, and also with sea warming. So, as the caption would tell you, by growing rapidly, the ecosystem adjusts to the changes imposed by sea level rise, increased CO2, and seawater warming, making seagrass a winner. But very few realize that. Next, please. Also, seagrass controls diseases. This is one of the latest findings. As shown to you by Massa, the evolution of oxygen through photosynthesis, that is creating a condition that is favorable for reducing exposure to pathogens. And a very isolated work, for example, there in the upper right-hand corner, it says corals had 50% less diseases when seagrasses were nearby. So, high five. Next, please. Also, seagrass preserves our cultural heritage. This is exemplified in Alaska and, as Masa showed you, in Japan. But because seagrasses creates the conditions favorable for artifact preparation, oxygen, less of those pathogens, the reduced movement, especially the strong movement of seawater. Next, please. And let's make a brief mention of the issues and concerns because there are a lot. I'm showing this figure, but this is a threat and the impacts of those threats to seagrass and mangroves as blue carbon ecosystems. And of course, what I'm going to emphasize are the root causes. I need not, and I think I don't have the time to go into each one of these, but please focus on the colorful three smaller concentric circles, the middle. But first, of course, the dark green are the threats, the orange ones are the impacts. But the ones that are emphasized are the three root causes, especially in our region. If you look at it quite closely, it says, of course, I cannot, it's too small for me even. What is this? Weak law enforcement, ineffective governance, and knowledge gap. Quite obvious. After decades, we still are facing these root causes. In other words, all of those threats, impacts are caused by Actually 7 in all, but the other 4 are not so much applicable in this particular case. So I am mentioning only 3 root causes. Please take note: knowledge gap, especially science and social science, natural science, weak law enforcement, and ineffective governance. Next, please. Some concepts are very useful in understanding why we should monitor and what we should monitor in Seagrass ecosystems. The concept like impact propagation. How does impact propagate? As I am representing it here with a figure on the tsunami height. It starts from the red dot, that's the source, and then goes up, propagates itself further and further. But in the process, I am superimposing it into the levels of biosocial organization. By this, I mean closest to the red area source are what you call the communities and species. And after this, the higher level is ecological systems or ecosystem. And then you go up, ecosystem services, and upper, you have the human well-being, the social level, and also including the legal and social imperatives. All of these are impacted by a simple, for example, threat or issue like pollution or deforestation. The features of each of these levels are written after each of the levels. So for communities, you have, for example, diversity and density and cover are affected. Ecosystems, the components are affected, and the processes like sediment filter and so on down the line. And especially if you deal with communities, ecosystem services are jeopardized. Human well-being, this is quite interesting because from you ecosystem services, we are actually deriving or we are identifying our well-being like security, basic material for good life, health, recreation, good social relations, freedom of choice and action, and information. And of course, the legal and social imperatives like planning, social mobilization, EIA, and so on down the line. So if you impact a seagrass bed, you are actually impacting a whole gamut of other levels, including even, by the way, because of connectivity, coral reef, seagrass beds, and even the forests. I think we should really change our mindset to or into that particular thinking. Otherwise, we lose our precious natural heritage. Next, please. Of course, the other concept I'd like to introduce is the concept of factor interaction and causal effect. This was partly mentioned by Professor Nakaoka. Along the eutrophication gradient, this is in Bulinaw, by the way, Bulinaw, Pangasinan, where the major impact is brought about by the fish cages, eutrophication from the fish cages or nutrient discharge from those cages, and then there is interaction with the variables that we have identified. For example, in this particular case, you identify or you see those yellow varying sizes of yellow objects. Those indicate the amount of dissolved nitrogen, phosphate, silicate, in other words, the nutrients. The biggest one is or identifies the fish cages, the source. And then our station starts with the station 1 below the beginning of the arrow and then goes up to station 2, station 3, and station 4, which is in the seagrass reserve or where you have the healthiest of the seagrass and very close to the coral reef. Now, what variables did we monitor? If you look at the arrows at the right, the first 3 ones are directed or pointed upwards, and the last 4 are directed downwards. The first three, Malaysia, density and cover, biodiversity, fish species. This means that from station 1, closest to the impact source, to station 4, the cleanest, you have an increase of those parameters, the value of those parameters. On the other hand, you have the last 4, which is inverted. Fish individuals, above ground, below ground, biomass, and hollows, density and cover, growth rate, and in fauna. All of these parameters, their values went down as you approach the source of eutrophication. It's quite clear how in monitoring this could give you a good picture, a realistic picture of what is going on in the system. Next, please. And this is the one that I emphasized earlier. We have to know in monitoring, not just that process, that stage where we go out and get the data, but we have to start with development of the network, which also starts with assessing user needs, define the objectives. You know, this is a bit common to scientific endeavors most of the time. We assess, we ask the question, why do we have to monitor? We have to define our objectives. Why do we monitor? And then review existing knowledge networks, implement monitoring system, which could come in different forms. And then that is the time when you go to the field, collect data, and especially in the community practice, you involve citizen science, where ordinary citizens work together with scientists to come up with data gathering, even analyzing. And after that, you process and store the data. And lastly, you share, you analyze, and you report to make it useful to many. I said, this is the step, or these are the steps that are commonly not considered in sequence because it's a complete set. You cannot just monitor by going out, collect the data, and share. No, you have to consider it from end to end. Next, please. Now, we go to the meat of the paper, community practice. What is it? I am quoting it from the very original source, Banger, 1998. A community practice is a group of people sharing a concern or a passion for something they do and learn how to do it better as they interact regularly. This is a bit far from science that we've been talking about, but this is it. You have to involve the community. Now, what is a COP? There are 3 components normally: domain, community, and then the practice. With domain, I have identified, for example, Southeast Asia as our domain. We can make the world our domain, but let's simplify it. So domain is our area of shared interest and key issues. Our community, the government. Community, research, indigenous peoples, education, industry, economy. There may be others, depends on the place. But our community is built through mutual sharing and learning to pursue the interest in our domain. And finally, we have the practice for our shared products and resources. Like, for example, maps, what we go and get in the field, applications, portals, experiences, stories, and even solution to problems. So these are the components of a community practice. It cannot be, that community cannot be complete without any one of these. Next, please. Now, we go to the question on why community practice is a best approach in solving the problems. On the left, the bigger letters there, it connects people and creates an avenue for people to interact, pool resources, and work in partnership. But in more details, I've included 7. Why is it that they do what I have just mentioned? Because they enhance collaboration. They innovate and create new ideas and knowledge, ensures professional and even personal development, solves problems rapidly and easier, develops and shares best practices, encourages knowledge sharing that leads to cultural change, and contextualizes issues and concerns, especially the last 3, which are very uncommon. We have to mobilize community so that a change, even cultural, can occur. A change in attitude, in behavior. As important will be number 7, community practice contextualizes. In other words, it puts the issues, findings in their proper perspective. Localized. And I think we have been doing things in the field, have been gathering data, we try to solve solutions, but then where do they usually go? Those results, publications are more often than not, more than 80% goes to publications which are not available to the people where we got the data. This is not fair. So let's contextualize so it will be used directly to people where you got the data in the first place. Next, please. Now, just to show you some of the monitoring methods, the very first at the left, they're very small, but it was shown partly by Dr. Anchana. What I have here is a composite methodology, including satellite, low altitude photography like the LiDAR, and the drone. They are combined. And then below you have the socio-cultural aspects of methodology, which involves the community, the people, the normal citizen. And then, of course, the normal thing that we do quadrant sampling. And that guy there, at the upper one with the earphones, that's Len Mackenzie of Australia doing monitoring using helicopter. We cannot afford that, but it's being done in Australia because Australia is so huge, Seagrass bed. And then the 2 literatures which are quite popular, the Seagrass Watch, the one on the left, and then the Seagrass Net on the right. This exists since the late 90s, which we developed to monitor global seagrass status. And then, of course, as I said, the social aspect, which I'll emphasize in the next slide. I am emphasizing this because we are talking about community of practice. So the next slide, please, will show you the 4 basic steps in doing a social transect for seagrass. You start with number 1. You orient your participants on seagrass. What are they? How to identify all of those. And then 2, you interview people, for example, because people, the local people would know best how they use the seagrass. We cannot just assume that if one country uses it like this, then it will also be used in the other country. No. Let's be more contextual in our approach. And 3, data input and validation. And 4, we have to consult with persons of authority. This is participatory, localized approach, and a welcomed one, which I'm trying to really promote for us to do, because first, in our region, we have manpower as a number one resource. We have to teach them to do the monitoring. Otherwise, how many scientists do we have? How many students do we have? They cannot be as effective than people who directly use the resource. Students use them for academic reasons. That is a good excuse. But for me, why not do it for people who are directly using it so that they themselves can improve or enhance what they're doing, especially in relation to their livelihood? Next, please. Well, this is quite small, but just give you an idea of the current Seagrass observing networks globally. What I'm trying to give you here, and I'm sure the organizers can give you a copy of this. I'm mentioning the observing networks like Seagrass Watts, the Smithsonian Marine Geo, local and regional programs. But what are they addressing? What are the scales being captured by the network? The observing frequency, the sensors or the techniques being used, and even the accuracy, and of course the reporting mechanism. This is what I meant when I said it should be complete. When you monitor, has to be reported, especially to people who are concerned directly. Next, please. And I'm trying to conceptualize, after saying so much about the community of practice, how is it related to governance and ecological resilience? I am looking at it hypothetically as a COP would be very useful in linking science, policy, and practice because you're dealing with the direct beneficiaries of laws, ordinances, the people, the community. And then, of course, with that knowledge, which are contextualized, and it's very easy or easier to come up with ecological resilience, climate change. And when you are, or when the community is resilient enough, then it enhances the community of practice. And the whole process is repeated. It is iterative. It's a feedback loop. COP as a platform linking science, policy, and practice for ecological resilience at multiple scales, from the smallest community to the national government. Next, please. Now, in my initial study or research of COPs globally, I came up with 61. And having 61, they attest to the platform's effectiveness in Seagrass research and monitoring. Look at the distribution. I said this is not complete, but 32 of the 61 have very clear Seagrass science to policy mandates at different levels. My plan is for, there are 5 clusters. You look at C4, that's actually the Western Pacific. I am planning to really call maybe a Zoom meeting of those involved directly in this identified COPs. And let's talk about what we can do with our regional COPs. One of these days, I'm going to communicate with you. Next, please. Of course, there are challenges. Take note of the challenges, especially these are graded. The tallest bar is the most or the greatest challenge, even to this decade. Recognition. Because seagrass is really not that well appreciated compared to coral reefs and mangroves, tidal marshes, the forests. And then comes status and condition. This means that we really know very little, especially about the distribution, where they are, how they are. And then threats and impacts, balanced needs, and these balanced needs define, for example, how do seagrasses impact or balance the needs of the planet and local needs. And then comes science support. Well, I'm happy that in science support, the literature that's present in seagrass nowadays started from the 1970s up to the present. They really have soared. There are no many sizable in the region by local authors. And of course, climate resilience is understandable because we don't know much yet about climate change. So seagrass, we also know quite little. So next, I think it's my last slide, a take-home message. Allow me to read it coming from Steve Trent, that is the Executive Director of Environmental Justice Foundation. Seagrass meadows are home to up to 40,000 fish and 50 million vertebrates in every acre. But we lose the meadow the size of a football field every half an hour. World leaders must stand up for these unsung ecosystems. Thank you very much. It really was a pleasure. And thank you again, Abe, for playing slides for me. Thanks.
Tak. Ayah you dah tak join.
Thank you, Prof. Mike. It was a extremely humbling presentation actually, and it culminates your experience and there are so many things that we can take it from your slides. Thank you very much again, Prof. Mike.
Welcome.
And yes, so now we have about
just one
now, yep.
just one word if I may interrupt. The last 5 slides are actually literature sources. So if those interested, you refer, and I can give you a copy of some of those. I don't think I have all of them. Thank you.
Thank you very much, Prof. Mike, for sharing. Now we have about, well, we are just right on time, about 30 to 40 minutes for discussion, or is there any questions that we want to pose? Before that, I would like to invite Prof. Eileen to sort of give us an overview, not overview, a summary of what has been talked about and how do we then move forward for our discussion in the next 30 minutes or so. Prof. Eileen, the floor is yours.
Okay, thank you, AB, for giving me the opportunity to give a little bit. I would not say an overview, a bit of comments, and of course, thank you to Prof. Nakauka, who is not able to be with us, but has taken the initiative to prepare the presentation. And to Mike Fortes and Anchana, have known both of them for a very long time, even during my student time, I guess. Good to see both of you, and thank you for your wonderful presentation. It was a good learning process for me, listening to the champions in seagrass research, particularly in the region. So our research team, and talking on behalf of UC Science Malaysia Center for Marine and Coastal Studies, CIMAX, has actually been working on the seagrass meadows in Merambung Shore and as in the southern part of peninsular Malaysia, as well as in Gazumbo Island, located on the northern part of the peninsular Malaysia. If you look at, if we remember Prof. Fortes and Anchana's slides, we have a lot of research Malaysia is actually located in the biodiversity hotspots, and we have the highest, most probably in the region, highest density of seagrass areas in Malaysia itself. So CIMAX has been monitoring the seagrass meadows, in particularly Gazumbo Island, for more than 30 years. Yet there are still many more research or things to be discovered and conducted in this area. This year, the local government of Penang itself finally decided to gazette the seagrass bed into a marine sanctuary. So I wish why I'm mentioning this is to highlight that it took us many years and decades, in this case, to convince the policy makers and local government on the importance of seagrass meadows to the environment. This could not be a reality without long-term monitoring and baseline data and without science policy interface. So one of the key concerns of scientists and researchers, like what been mentioned by Professor Fortes, is networking. How do we bring people together and to work together for the benefit of the people and the environment? Not just bringing together the scientists, but the government, policymakers, public, community, and industry players to be on the same boat. Just bringing together maybe under what Prof. Mike Fortes has mentioned, community of practice. Quoting Mike's comment on networking development, assessing the needs of the user, define objective, review existing networks and way to be sustainable. We may also need to look seriously at the Blue Carbon Network initiated by Dr. Anchana in Thailand, and most probably hoping that the same initiative can be shared and be spread to the region and maybe to the global arena, and see how we can establish and sustain this network. We need to move towards the era of synergizing our efforts and skill, no longer about working in silo to solve global issues. Maybe community of practices as the best approach. Many workshops and training we have conducted, but the main question is, we are talking about this very intensively. Despite many workshops and trainings being organized, what is more important is how many of these trained mentees or participants continue what they are doing back home when they return back to their lab. Many times the scientists and researcher main focus would be the science, the seagrass in this case, but there are something important that we need to address too, besides doing the science we want for the ocean. To fully implement or practice best practices, we need to discuss about transparency, building trust among scientists, especially when it comes to data sharing. So how do we adopt best practices to suit the local scenario? So the concerns such as standard best practices and affordable best practices, especially very relevant to our region, in terms of affordability and also in terms of practicality. So I think this might be start off for our discussion. So back to you, AB, to lead the discussion. Thank you.
Thank you very much, Prof. Eileen, for setting up the mood of the discussion. And I think among of us, we have about 22 participants only for now. But this session is being recorded, and it will be shared around for people to have a look. So I would like to now open the floor first for anybody who wants to ask any questions or to want to give any comments to any of our speakers that have presented their work. Is there anybody who wants to make a comment or question? Currently, there is no one who wants to ask any question. Or Nitya, do you want to ask any question?
Yeah, maybe to thank you, Dr. AB. I would like to ask Dr. Anchana. It was a very interesting presentations or sharing from all the panels. I would like to know about what is the success rate of the seagrass restoration effort that being done in Thailand, and also what is the common species or the best species that always been your choice for the restoration, and also if usually it's just one type or also the multiple type in combination for the restoration. Thank you, Dr. Anchana.
Thank you for the question. This is a very challenging issue, I have to say, with the restoration. The success rate, to be honest, really low. And the limitation is once they go for the restoration, the monitoring never happen. They just go CSR, taking picture, and then that's it, that's left. And that costs a lot of money to begin with. So as a scientist, maybe we have to reach out a little bit further. Saying that, I think that the community is already there. They have the awareness. The private sector putting the money in, they already being interested, being the key player. But the best practice to get together and let it carry on, have a good monitoring, and then to be success. That's still another story left behind, right? So the success rate is very low, I have to say. The species that we normally do would be Enhalas. I have to say that our lab, we don't really do the restoration because we know the limitation, the difficulties, the toughness of doing this. So whenever we have a chance, we would promote the conservation, have a good management with the threat, right? Because the seagrass itself, they grow fast, actually. That's a good thing about it. They also a tough organism. So we just have to find a good balance to do it. Okay, so Enhalas is a very probably the most dominant species that we do. But we understand the importance of the restoration because all the picture is there. So we ourselves have just start to have look into the other species like Thalassia, Semodosia, and also the Halophila. And then the technique that we use is just plug technique methodology. So wait a little bit. The success is quite better, but again, the cost to do the transplantation, the conservation, probably a better choice, I think. So we should have a data coming out quite soon because we have to do the transplant, we have to monitor and see how fast it's getting there. So we would have other species to pick up. Okay, that's about it. But underlying is conservation would be the best solution. Thank you.
Chana.
Thank you, Nitya, for the question. I want to also move the discussion a little bit on, especially on monitoring, to Prof. Mike and Dr. Anjana, both of you. And there are a few now, at least, monitoring standards. For example, Seagrass net has been there for almost 20 to 30 years. And also recently, we have now blue carbon kind of monitoring method that has been established by IUCN. How do us as community or practice, I would like to use that word now, how do we then sort of standardize or make sure that all these methods are comparable across the globe? Because we have now many different kinds of standardization now. Is there any comments on how do we move forward for OBPS also to sort of come out in kind of suggestion to people? What do we move from here with our different kinds of standards now? I think both of you can give your comments if that's possible. Dr. Jana or Dr. Fortes, which one of you want to go first?
Fortes would be the best one here. Please.
I thought it's ladies first. Okay.
For Fortes, why not you first? We have been doing this for more than 30 years. So what is your comment throughout
Okay.
your
First,
experiences?
first of all, Dr. Ranchana mentioned the manual for blue carbon that we published way back in 2014. We tried to revise it in 2018, and there is again an effort to really make it better. And by better, precisely this point, how can we standardize? Because of the variations globally, the species, conditions, how do we standardize? In the methods, if you look at the literature, there are standard methods. But those standard methods are focused on very few serious species, and most of them are temperate ones. in our region, in the tropics, there is really not much yet. But we are working on what we know from the literature, that it helps a lot. Our latest publication with Anchana, of course, was there. We have um, we have measured blue carbon sequestration and even release and even prospects of increasing and how much blue carbon we will be earning. Those are still part hypothetical, but we are going into that direction of coming up with a practical standardized methodology. Now, having said that, I'd like to emphasize the point that it really should be localized. First of all, localized. We tend to adapt to what has been published in literature, which really has nothing practically to do with the conditions we are in. Anchana and her group in the university, my group, Singapore, even Vietnam, even Cambodia, they're trying their best to really come up with these values. Now, I'm hopeful that we can really come up together and then talk about standardization because we have common species. We cannot use the values that are coming from species like Zoostera marina. We have in Vietnam Zoostera japonica, but it's quite far. So what I'm trying to say is, again, localize, contextualize the issues. But the efforts are there. Let's help each other build the network and communicate well, and then focus on what we really want to do with seagrass. If we want to focus on blue carbon, why not? Because blue carbon has perked up. There is becoming more and more literature, local literature on blue carbon. Thank you.
Thank you, Prof. Tanjana, do you want to give your comments as well?
Yes. I just feeling grateful actually for the kind of workshop. I start doing Seagrass because I have a chance to attend the workshop, leading by Professor Mike Fortes. Actually, at the beginning of the slide that he put, that the first one is in Libon.
My
That,
goodness.
that is when I start to learn about the Seagrass,
You,
2003.
Anchana, you are making me too old.
Then look like just the simple workshop monitoring, so we can really sharing the knowledge and then put our good effort together, having the network. I think this is how lucky we are also in the region that we have a very prominent established professor to lead us, and then simple kind of workshop can go a long way, I think. And nowadays things are become much more easier. We have online platform. We are able to share using the technology. So there are a lot of hope there. I think just get together, sit down and talk, and then identify the goals together. And it's a great opportunity for the region, I think, because we are hotspot biodiversity. So we should be the one that contribute much more about the seagrass out from the region. That I like to add. Thank you.
Thank you, Tanjana. I would like to ask Prof. Eileen, because she said about most of the time. Yeah, I think from Dr. Anchana and Dr. Fortes, both of them agree that workshops and standardization regionally is a very important aspect. But Prof. Eileen did mention about how do we then have a continuity after the workshop so that those things that has been learned will be implemented as well as the network will continue to grow. Do you have any suggestion on how do we move forward? Usually after the workshop, how do we maintain such best practices for everybody to be used in their local community?
Well, that's a very difficult question for me to give solution, right, Anchana? Because sometimes, workshops, agencies, ministries, or even institution, when there's opportunity, we do send participants or representative to attend workshops. And many times I personally feel participants or the trainees that came back, some of them like Anchana, when she attended the workshop host by Mike, she came back and she continued doing it, and she's very unique, in that sense. But I think she's an endangered species here. Because many came back after a while, their attention divert, and also like what Mike has mentioned, the determination factor can be the funds, can be the facility support by their own institution is not there. So somehow or other they have to forego what they have learned and do other things. So that is very much depend up to the institutional support, the individual interests, and how they want to move forward. So what need to be measured is not the numbers of training workshops to be conducted, but the numbers of how many continue to do what they have been taught. Yeah, that's I've no solution, I've no solution, Abby. Maybe Mike, can enlighten us on this thing. From your experience, the numbers and hundreds and maybe thousands of students that you have guide.
Okay.
Yeah.
Okay. Okay. I'm happy to share with you.
Yeah.
You said my experience. Okay. Now, first, I'll start with why is there a very few group or a small group of people in the region who are doing seagrass. And I will mention this small group. Anchana, Yom of Thailand also, Japar of Malaysia, and his assistant, and then
Utara.
yeah, and then Triedi, Korean Dewa of Indonesia. And now come a little later, you have Singapore group as a group of Seagrass. Still students are very young professionals. Now, question is, why is it that ever since and up to now, we are still doing Seagrass? It's not that, I don't know about Anchana, but we are not receiving any remuneration for doing this. I have identified a key factor here. It's passion. It is passion. Now, having said that, passion, it has to be with a core group. There has to be a core group to initiate, to police. Oh no, I have, I don't know if you consider this a dirty thinking, but you have initiated this webinar. Would you want to be, or would CEMAX be a core institution for this? By the way, last October, I was invited also to speak at the University of Malaya Borneo Marine Institute. Is it? Am I correct? Because they is initiated a blue carbon discussion. So that's a good start. We can follow this up with CEMAX. Now, I have said one of the things that causes the failure of what I call the community of practice is the absence of a core group. The other one is it becomes, the one-to-one connection between the members. They become weak through time. So sustain. How do we do that? And then rigidity of competences. You know, um, it's very difficult to say, but scientists normally evolve. I make myself an example. I started with an honest to goodness scientist, a hard, poor, scientist, but I have evolved to become a scientist that is inclined to help people. In other words, there is a social dimension of my science, and that is supposed to be the one that we should be doing. There is always the conscience, the social conscience of science. Otherwise, your science will not be useful. And then we should be identified with the network. Network is for now the simplest thing that we can do. There are a number of networks, but we are not focused as yet. There's one or two network on blue carbon, and even on Seagrass. And there's even a global Seagrass network initiated by UNEP in Norway. But we have to tap this. But again, I mentioned earlier that I might just be communicating with a community of practice in our region, the C4 Western Pacific. Now, maybe I would like your comment on what I'm going to communicate with you because we really have to initiate this. Okay? So I think it's really a core group that we should start with. Thank you.
Thank you, Sir Mike. I'm taking some notes so that I can come up with the writing up later on. We have barely about 5 more minutes to go. We are really on time, which is great. I would just like, is there anybody that has a burning questions that they have to really ask? Anybody from the floor before we summarize this in quickly 5 minutes. Okay, if there is none, I have one last, maybe each of you, three of Dr. Mike, Dr. Anjana, and Dr. Eileen, could you give me your last comment in wrapping up? What is your hope? And just one or two points that you want to leave so that I can put it in report. What is your hope for, especially for seagrass monitoring best practices? Just give me one or two points that you think the most important thing that you want to do moving on towards monitoring the seagrass area, not just for regionally, but globally. We'll start with Prof. Eileen, and then we'll go to Dr. Anchana, and then we'll close with Dr. Mike. Please, Prof. Eileen.
Okay, thanks, AB. My hope, following to this webinar, is like what Mike have mentioned, to establish a group, a network of community of practice who is passionate enough to continue and work on this area. And of course, we would like to see more younger scientists, because like, in the discussion, Mike has been in this field for 30 years, and Chana also maybe 20 years. We are considered in our sunset phase. So we need to quickly groom new passionate scientists. So that is also important for sustainability of for the better future of the seagrass. Thank you. Back to you, Abby.
Thank you, Dr. Eileen. Dr. Anchana, who has been working for 20 years, she is revealing all our ages now, and that's not fair. Dr. Anchana.
Yeah. So I myself believe in research and education. That's my belief to begin with. And then along the way, I learned quite a lot from some of the example. Like for example, my fortress. He also saying side to policy. This is something I learned, and I hope that we can do something more on that. I learned that science is going to be helpful, useful for the locals. They are there. We are scientists. We have to come back. So this is a few things that recently I has to be thinking a lot more. Side to policy. We have to help the country. We have to be the one that probably put more on the impact using our side. The education itself, right? That's why I do my work in the university. And education is building up the young scientists. Education is not just only the science itself, but I think being educated, so you will be able to do things in whatever you like to do. Seagrass is just one of them, right? But you would have a good quality of life. So that would be my belief, science education. And luckily, with the networking that we do have, it makes things more fun and it's opened my horizon actually. So that would be my last few words here. Thank you.
Dr. Anjana, very, very wise already. Prof. Mike, do you
Okay,
want to
thank you.
give us some wise words?
Nobody will disagree with Eileen and Anchana, what they said. Nobody, because they're really right. Now, having said that, I am trying to look at seagrass nowadays. You know, I am wearing a smile almost every day now because we started doing research, studies in seagrass with practically nothing. But now, wow, it's in the limelight, it's in the Facebook, all of those things. But I'm trying to espouse community of practice because, as I said, science has a social conscience. And that is one of the biggest problems that has been identified even with blue carbon. What is lacking is the social conscience. That is why there is a global conference regularly on the social responsibility of science. Anyway, having said that, community of practice involves people, and when we deal with people, here comes the problem. And this problem is ethics. With people, ethics comes in. By ethics, I think we should all make the effort to minimize the risk. Otherwise, I don't think that people will join you in that work. We also have to get their informed consent. I remember this is one of the principles of ethics, obtain informed consent. And we should also protect anonymity and confidentiality. And of course, in science, I hope I'm not disappointing scientists, but let's avoid deceptive practices. You know, whoa, you can look at the literature of what some scientists do is really bad. Let's not go into that. And then, of course, if you're in a network, let's provide rights, especially, for example, if you want to withdraw from the network, by all means do that. But do it, of course, very gently, very politely, with respect. This is what we are now because we deal with people. Because seagrass has just started to perk up. And I really don't want seagrass to suffer the fate of coral reefs, of mangroves, of forests. They have suffered so much precisely because it's based on ethics. That's my 2 cents worth of contribution for this part of the session. Thank you.
Thank you very much, for Mike. I like the idea about working with humans, and after all our scientific work works with the environment, who do not speak, who do not, So at the end of the day, it's managing people and managing the network that really will sustain our work.
That is
Thank
true.
you very much.
That is
Thank
true.
you very much. Thank you very much, Prof. Mike, Dr.
That,
Anchana,
that's
Prof.
very,
Eileen,
it's very true, very true.
and of course Dr. Nakaoka, who is not here. I would like to request everybody, if you can, to switch on your camera so that we can see you, so we can take a group photo, and then we can put it in our report that there are many people who attended, and so that we can share it around. Okay, 1 more minute for everybody, 30 more seconds. Yep. Okay. All right. right. Okay, I think can we take a photo together?
Thank you very
Yeah.
much.
You can.
Yep.
Okay.
Okay. All right. Give me your biggest smile. 1, 2,
On the
3.
seagrass.
Hang on a second. Let me. Okay, let me take one more.
One
Okay,
more.
ready? Yes. 1, 2, 3. Okay, got it. Thank you very much.
Thank
Thank you
you.
again.
Thank you very much,
Good
everybody.
luck.
Thank you. Thank you.
Take
Thank you
care.
for your time. Thank you, Jay. It's
Take
very
care. Yeah.
early in the morning or late in the evening. Okay, we'll maybe we'll reconvene again in the next time and next session. I'll be in touch with everybody. Please put in your details around this in the chat box so that we can get connected with you and for our future work or building networks. Jay, you want to say something, Jay?
Yeah, I just wanted to say that to all of us, the access through Kiko Chat gives you Zoom and a session, and it's available all next week. So if there's any discussions we want to have, you can go to Kiko Chat and just go to this particular session and open it up and meet there. Thank you. This
Thank you,
was
Jay.
really a great session, by the way. Thank you very much.
Yeah, thank you very much.
Thank you, Jay.
Okay, thank you, everybody. We'll see you some other time in some other sessions.
Yeah.
We'll keep in touch, Dr. Mike, Dr. Anchana.
Thank you,
All right,
Mike.
bye, everybody.
Hope to catch up with you more. Come to Penang. Left.